Hi guys. Hey, I have your lesson for you guys today. It is December 3rd of 2020, and here's what we're going to be working on today. We have been studying slope-intercept form. So if you guys remember, this was when we were talking about the equation y equals mx plus b. We were talking about this being the intercept, the y-intercept, and then this is the slope. And when we're talking about slope-intercept form, how do we go about graphing proportions, things that are proportional and things that are not proportional? So remember that we studied proportions. We did that right before we came in and we learned about slope-intercept form. So I talked to you guys about things and where the sets of data relate to each other and they can constantly relate to each other. So that would be something that's proportional. If we have data sets where they don't relate at a constant rate, then that's not proportional. So we're going to be given some data sets and we're going to determine how to graph those and how just to look at a graph and know if it's proportional or non-proportional. So what you guys are going to be doing today is the very, very first thing that you can do is you guys can watch a video that I posted. It is a YouTube video. That YouTube video goes through your guys' notes and it's just another person explaining your notes to you besides me. Your notes today are going to look like this. They're just a one-page set of notes, which is amazing, super easy for you guys. So at the top, it tells you guys to do slope-intercept form, and it writes it as y equals mx plus b. And you do have a little QR code that you guys, I don't know if you can, take a screenshot of it and then somehow use your camera to get an image shot of this. But if you need to, you can QR code to the video through here. It's also in Google Classroom. I think the best thing for you to do is just go under classwork and click the video and watch it. What you guys have is you guys got two different situations that we're going to be investigating closer. We're going to be looking at those graphs. You got a table to fill out for both, and then we're going to graph both, and then we're going to get the equation, and then you're going to talk about what do you notice about a proportional graph and then a non-proportional graph. So to start off, what you guys are thinking about is you guys are considering this person, Jennifer. Jennifer charges 15 hours to babysit at her home. So what you guys got is this scenario where she charges $15 an hour to babysit, and that's at her home. So you would be bringing your babies over there, and she would be staying at her home, and she would be babysitting from there. So you guys got this table that you're going to fill out, and it says hours, and then we got a cost. And this is pretty typical. What we're trying to figure out is how much would it cost us to have her babysit for us. So if we start out and Jennifer didn't babysit for us at all, if Jennifer didn't babysit and she put in 0 hours, we would owe her nothing. She didn't work, so she didn't get paid anything. So 0, 0 would be 0 hours and it would cost us $0. Now, if we switch though and we go and drop our babies off over at Jennifer's house, Jennifer would look at 1 hour, and at 1 hour she would say, you owe me $15. Now we're going to jump down on our table, goes to 2, it goes to 3, and it goes to 4. If she was to do 2 hours, it would be $30. So what we're seeing here is we're seeing that this is raising by 15 and then another 15. If she did 3 hours, it would be $45. And then if she did 4 hours, it would be $60. So we have this constant rate of change that's happening here where you guys are looking at to go from one to the next, that we're just increasing by $15 all the way across. Every time we add another hour, we're increasing the money that we owe her by $15. So now what you guys can do is you can look at this data set and you can look at it like ordered pairs. This would help us graph. So I'm going to look at this very first one. Remember that we came up with when she works with 0 hours, she gets paid $0. So that's our first ordered pair. Our next ordered pair, if she works 1 hour, we pay her $15. If she works 2 hours, we pay her $30. If she works 3 hours, we pay her $45. And finally, if she works 4 hours, we pay her $60. And this data set would just keep going. And this is what's going to, if you guys even just looking at this data set, you can go 0, 1, 2, 3, 4. That's a constant rate of 1 that's being added. And then 0, 15, 30, 45, 60. It's like you're counting in multiples of 15. Constant rate of change is happening. Since we have a constant rate of change happening by a linear model, we should be able to plot all those points and then draw a line straight through those. So what you guys are going to do is you're going to jot down. What's great for you guys, super helpful, is that you guys actually have a grid. So you're going to have to bear with me. I don't have the grid. I'm doing the best that I can just using this whiteboard. So what you guys got is you guys got just quadrant 1. So we're just looking at the positive side of the x-axis and the positive side of the y-axis. We're looking at that quadrant 1. We don't have the entire x and y-axis drawn out where we have all 4 quadrants. We're just looking at this positive quadrant. And what you guys have listed down below is you guys got 1, you guys have 2, you have 3, you have 4. It keeps going, 5, 6, 7, all the way up to 10. I don't have to go to 10 because I know I'm only going to go to a 4 when I'm plotting my points. On the other side, it looks like they went and implement the increments of 5. So it goes 5, 10, 15, 20, 25, 30, 35, and it would just keep going. Now, what I'm going to do is I'm going to start off and I'm going to plot this very first point. 0, 0 is just that origin. It's just right here in the center. So I have not left or right, not up or down, 0, 0. My next one is 1, 15. So you guys are going to go up to 1 and to 15, and you're going to put a dot right there. Then we have 2, 30. So you guys are going to go to 2 and 30, and you're going to put a dot right there. Then we have 3, 45. So you guys are going to have to expand yours, and you have to go 3 up here to 45. And then you would do 4 up to 60. Now mine's getting cut off, but clearly you guys only need 2 points, and you can see your linear model. You can see your line that's going to come together. So all you're going to do is you're just going to attach all of those dots to each other. Put your arrows on both sides to say that this keeps going on forever and ever and ever. Got your linear model. Oh, and actually it ends on that side right there, but we got our linear model that's going to be represented right here with these 4 coordinates that we came up with, these 4 points that we plotted. So there's our first scenario where Jennifer just gets paid $15 an hour. Okay, we graphed it. Oh, and then right underneath that, it says, what's the equation? So when you guys are talking about an equation, it's asking you guys to come up with the equation. And I am thinking to myself, y equals mx plus b. So when I'm going to write this equation, remember your y and your x always stay just the unknown variables. So I will have my y, I'll have my x. I have to figure out the b part. So this is my y-intercept. This is where does it cross the y-axis at. And if you remember, we had this origin point, this 0, 0. If you look at that graph that you guys just drew where the line kind of went like that, you guys are going to look at that graph and you're going to say, okay, where does it cross the y-axis at? It crosses the y-axis at 0. It crosses at 0. So that this part right over here, this plus b part, would be plus 0. Now I have to figure out the slope. I got to go, okay, what is my change in y over my change in x? So you can take any of these points and you can go change in y over change in x. So I'm going to look at these two, like I can begin with these first 2 points. To go from here to here, from 0 to 15, remember that I was just adding 15, 15 to 30, adding 15. Each one of these, I'm just adding 15. That's all I'm doing. These, I'm just adding 1. So change in x, all I'm doing is adding 1 straight across the board. So my change in y, so as you guys are looking at your slope, my change in y is what's happening as I go from one y to the next, which would be 15. Change in x would be 1. So change in y over change in x, which would be 15 over 1, which is just 15. So all I get is 15 for the slope. And then remember, you do not have to write the plus 0 part. So you guys, this equation would just look like y equals 15x. There's your guys' equation. So y equals 15x is my equation for when Jennifer only works and gets paid $15 an hour. So I filled out the table, we plotted the points and we graphed them, and we come up with our equation. We have a different scenario on the right-hand side that we're going to go through together. The scenario on the right-hand side says, well, Jennifer no longer charges just $15 an hour. You're going to want Jennifer to come to your house. And if Jennifer comes to your house, she charges $10 to just come to your house. And then once she gets to your house, she will do $15 an hour after that. So she's now got to drive, and because she's got to drive, there's an initial fee of just $10. So a little bit different in terms of our both our table and our graph, and how this is all going to come together. So when she does like 0 hours, she hasn't even worked in a minute yet. She's still driven to your house, but she hasn't worked yet. She's still going to charge you guys the $10 just to get to her house. Then once she's there, if she does that first hour, she has to pay the $10 and the additional $15. So she would be at $25. All right, so she's got the 1 hour and then she's at $25 now because she's done the $15 an hour and then she did the $10 just to get there. All right, now she's going to do 2 hours. If she does 2 hours, she's $15 an hour. So $15 times 2 is 30, and she still has to charge the $10 to get there. So that's going to be $40. If she does 3 hours, 3 hours, 15 times 3 is 45. And then she had the $10 that she charges just to get there. So she should be $55. And if she does 4 hours, you're thinking 4 times 15, that would be $60. And then if she has $60 and she still charges the 10 to just get there, that's going to be $70. Okay, so there's our points that we have. Remember, we can write these as ordered pairs. So we have 0, 10, we have 125, we have 240. These are all ordered pairs that are plottable that we can graph. So we're going to graph all of these points. We're going to connect them. Okay, so we're going to come over here. We're going to go to the next part. I really wished I had a bigger whiteboard. Sorry, guys. And we're still working quadrant 1, positive, positive. She can't work negative hours, get paid negative money. All right, so this is split again, 1, 2, 3, 4, and it keeps going. I'm not going to go past 4 just because I know I don't have to. And then on the other side, it looks like it goes 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. This would keep going, but it ends up on your guys's, it ends at 60, okay? So what you guys are going to be doing is we're plotting all these points. So when x is 0, we have y is 10. So when x is 0, we have y is 10. So our first point is going to start up here. Notice that this one does not go through the origin. That's the key right there. It didn't go through this 0, 0 point. Okay, the next point I have is 125. So I'm going to go over 1 and I'm going to go up to 25. The next point is 240. So I'm going to go 2 and I'm going to go over to 40. Next point is 355. So 355. And then I have 4. 4 is going to go up here to 70. So when you connect those, you get this line that kind of looks like this. Oh, it actually ends right there, but this line's going to go just like this. Yours will look cleaner. Yours will look nicer because you have the grids that go all the way across. So I got my graph that is done. There's my graph. Now it's asking me for an equation. So we're going to do this exact same thing. You're looking at y equals mx plus b, right? So you guys are looking at what is happening on where's the y-intercept? So that's my first piece is the y-intercept. Where is that at? This point right here, look at where it crosses the y-axis. It crosses at 10. So it looks like in this case, it's not 0. It looks like I have a 10 as a y-intercept. The y is going to stay the same. The x is going to stay the same. But I have to figure out my slope. So I got to figure out my slope. Slope is change in y over change in x. So you can do it however you guys want. You guys can look at what's happening here and count these, or you can look over here and look at your points and determine slope from points, or you can determine it from the graph, whatever one you're most comfortable with. It'll be the same. If I come over here, just notice that to go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, all I'm doing is adding 1, adding 1, adding 1 all the way across. So my change in all my x coordinates is, the change in my x coordinates is 1. Now the change in my y coordinates, when I come over here, 10 to 25 is 15. 25 to 40 is 15. 40 to 55 is 15. 55 to 70 is 15. So this is still 15. 15 over 1 reduces down to just be 15. So I still have 15x plus, I still have 15 as a slope. So my equation for this one, the overall equation, I have 2 different equations. And what I want you guys to notice is that with one equation, I got y equals 15x. The other equation, I got y equals 15x plus 10. The biggest difference between your guys' points and what was happening there, you had the same slope, same steepness, but one of them went through the origin, went through 0, 0, and then the other one went through 0, 10. So that is the difference between these two. When you guys are talking about a proportional relationship, when something is proportional, it will have no y-intercept, or it'll have a 0 y-intercept. So it's going to go through the origin. There won't be a b. This b is going to be missing. Whereas if it's non-proportional, you are going to, you will have a value for b. There will be a value that will go in there. So that is the biggest difference. This is, what is the difference between a proportional situation and a non-proportional situation? A proportional situation is going to go through the origin. A non-proportional situation, it is going to have some kind of a y-intercept, whether that's positive or negative. It will have a y-intercept. It just will not be 0. So when you look at equations, if it's missing a b, it's proportional. If it has a b, it's non-proportional. That's how you can just look at an equation and go, boom, boom, I know what if it's proportional or not. So you guys were given your guys' notes there. And what I have for you guys to work on today, I'm going to go look at this really quick. After you guys are done with your guys' video and your notes, I would want you guys to go and look at your guys' Nearpod. And then after you guys look at your guys' Nearpod, there is an assignment. And the assignment's asking you guys to determine proportional and non-proportional just by looking at some different situations. So I'm going to do like number 1 from your guys' assignment with you guys really quick. That number 1 is you guys, and I'm not going to be specific on the graphs here. You got A, so this is letter A, then you have B over here with an XY, and then you got a C over here with an XY, and then you got a D with an XY axis. And you guys got these lines that are going to go through here. This first line looks kind of like this. This line over here looks a little bit like this. This line goes like this. And then we got one more line that goes like this. And it's asking you to determine which one of these. Is it A, B? Oh, and I listed them wrong. I apologize. Is it A, B, C, or D is proportional? So our question is, which one of these is proportional? When you just look at a graph, we don't have to even look at numbers. Can you just look at a graph and determine if it's proportional? The key, the ticket is which one goes through the origin? Which one has that y-intercept of 0? The one that has the y-intercept of 0 is B. This has a negative y-intercept. This one has a positive y-intercept. This one has a positive y-intercept. So there will be a B value in slope-intercept form there. So my answer to number 1 is B. We're going to go down, and I want to look at number 2 with you guys again. Just to do a couple of these with you, I want you to have a couple examples. And then after we do these examples, if you still have some questions, I'm going to be available. You guys remember that I'm on GoGuardian, and I'll be here to help you guys. So you guys got these tables this time. So it looks like this. This is A, and then we have B down here again, I'm assuming. Yep. We have an XY table. And then we have C over here with an XY table. And then we have D down here with an XY table. And this is if I just give you a table this time. How do you know if it's proportional or not? Now, the ticket with this one is these tables, if you look at these tables, in the other example that I had like a value for 0. Like when X was 0, that's my y-intercept. I had a 0 here, and I could determine, was this 0 as well, or was this a value? If you're given 0 here, you look at this, this will tell you. If you have 0, 0, it's going to be proportional. If you have 0 with a number, it's non-proportional. But look at these ones. These ones all have 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. They have values. 1, 2, 3, 4, 5. There is no 0. There's like a 1, a 2, a 3, a 4, and a 5. Now we have this one goes 10, 22, 34, 46, 58. Okay. And then the B part goes 15, 27, 39, 51, 63. 51, 63. And then the C one goes 14, 26, 38, 50, 62, 38, 50, 62. And then the D goes 12, 24, 36, 48, 36, 48, 60. Okay, so on this one, what you guys you've got a couple options here, you guys. I'm trying to look at these and I can see that these all have a constant rate of change here. The constant rate of change is a +1 on all of these. So I can see that the change in X, I can see that we're just adding 1 as we're going from one point to the other. The other side, I'm trying to see what's this rate of change, what's happening to go from the one to the next. Is there a constant rate of change that's happening here? So 10 to 22, well, it looks like we're doing a 12. 22 to 34, 12, right? 34 to 46 looks like it's going to be another 12. And 46 to 58 looks like it's going to be another 12. So it looks like I'm like going 12, 12, 12. Okay, but the ticket is I got to figure out 0. When X is 0, what is Y? So when X is 0, I'm going the opposite. So I'd be subtracting 12, right, off of that 10. So 10 minus 12 is going to give me a -2. That is not 0. So this one is, that one right there is not proportional because it's going to have a y-intercept. Same thing, you're just going to go through these and you're going to determine what's happening when we're going from one to the next. So 15 to 27, it looks like there's another 12 that's happening there. 27 to 39 is another 12. 39 to 51, it looks like that's another 12. And then I got another 12. So this is still just 12, 12, 12. Now I'm thinking when X is 0, what is this Y? So you're going to take 15 and we're going to subtract the 12. When you take 15 minus 12, I get a -3. Or I get a 3, sorry, not a -3, I just get a 3. 15 minus 12 is just going to give me 3. There is a value here. This is not 0. Since this is not 0, this one is non-proportional. That one doesn't work. Go over to C. C, we're doing the same thing. What's happening? 14 to 26 looks like it's 12. 26 to 38 looks like it's a 12. 38 to 50 is a 12. 50 to 62 is a 12. Notice that I love these examples because this is the difference is 12. It's the same rate of change that's happening both with the X's and the Y's. The problem is when I'm trying to get to X equals 0, what is Y? I got to look at this 14 and I got to subtract the 12 off to get back, just back 1. So I'm going to go 14 minus 12. I get a 2 here. So I got 0, 2. So this one again is not 0. So that one's not proportional. This one's the same thing. 12 to 24 is 12. 24 to 36 is 12. 36 to 48 is 12. 48 to 60 is 12. But notice this time, when X is 0, here's my last one. When I'm going back 1, I'm going to subtract the 12 here. 12 minus 12 is 0. So D should be my lovely answer for number 2. D is my lovely answer for number 2. Sorry, guys, that's an awful lot of numbers, and there's a lot going on with that one. But I want to make sure I do those with you guys because I think that table is really, really tricky and really, really, really hard. I'm going to do one more and then leave you guys to practice some of these. I'm going to be here to help you guys. It's a lot of just you guys working and checking the rate of change and getting back to that 0 spot. When X is 0, what is Y? If Y is 0, then you got something that's proportional. If it is not, then you don't. So this time on number 3, we're given some equations. We have 15x plus y equals 0. And then we have 3 equals 15x plus y. Then we have y minus 15, x equals 5. And then we have y equals 5x squared. Okay, here's, tricky. I want you guys to automatically always eliminate whenever there's this exponent that's involved. That y equals 5x squared. I know this looks kind of like mx plus b, but look at this little guy right there. That little guy's going to change our whole graph. You guys aren't going to graph these for a while, but when we do, the graphs are going to look like this. They're going to look like something called a parabola. This is not at all a linear relationship. This is not a straight line. All right. So I want you guys to eliminate this one immediately. That's always going to get x'd out. We are not dealing with any exponents on our variables. That x and that y stay just to the first power. Now what you guys are looking for is, remember that you guys want to get these, so they say y equals mx plus b, and we want that b to be 0 because it's asking you for a proportional relationship, not the one that's not proportional. Not proportional will have a b. If it's proportional, it will not have a b. The b will be 0. It's going to go through the origin. So you're going to solve these for y is what you're going to do. So, this is 15x. Plus y. So that one says 15x plus y. So to solve this one for y, I'm going to subtract the 15x from both sides. So I got y equals negative 15x. And I can put the plus 0, but I don't have to. Now you guys are welcome to solve these other ones, but look at this right here. This one's missing because it's 0. Since it's 0, this one is my proportional answer right there. So my answer for number 3 is A. Now you're welcome, but I can look at these and I can move this 15x. I can go negative 15x plus 3 equals y. This still says y equals mx plus b. It's just inverted. I just flipped them. You can flip those equal signs. It can be on the left or on the right. These are still equal. This can come over here, or it can be written on the other side. But look at this. This one has a b. This is the b part right there. And I can look at this one and I can tell you right there that that 5 is going to be a problem. So I got y equals 15x plus 5. And this one has a b. Since they have b's on them, those are non-proportional. My only proportional one is letter A. So that's going to be your first 3 slides. The next slides I want you guys to go through and work on your own. So you're going to go through and you guys are going to finish out that assignment. Here's our to-do for today. And I would actually, if I was you guys, I would go through and I would watch that video, watch the video that explains Jennifer and her babysitting. So it's just another person explaining what I explained to you. So it's another way to hear it. While you're watching the video, get your notes taken and finish those notes because I assigned those to you guys. After you do the notes, I would go in and take a look at the Nearpod, because that Nearpod's going to reinforce what's proportional, what's non-proportional, how to graph those. And then the last thing you're going to do is you guys are going to look at this. It's an assignment. It's Google Slides assignment. So it is a slideshow, and you're going to go through and you're going to determine which one is proportional or which one is not proportional, whatever the question's asking you to do, based on tables and graphs and equations of lines. It's tricky. This could be kind of tricky for us. Don't forget your ST math. So if you finish all of this, our ST math has to be 60 minutes for the week because you guys had a full week with me. So you guys want to get that 60 minutes. And the last thing that I want to make sure that I do not forget is in this assignment, they use this word bivariate. So in the instructions, they say, like, for you to look at these different, they ask you guys to look at the different equations and determine which one's proportional relationship between the bivariate sets of data. Variate, think about the word variable. Bi meaning 2. So we're talking about, when you're talking about something like y equals mx plus b, there's going to be 2 variables in every equation. This is actually a number, and that number is the value for slope. This is a number, and that's our y-intercept. We have 2 variables that'll be in every equation. Y equals 3x plus 2. That x and that y are 2 variables, so that's what makes this a bivariate equation or bivariate relationship that you're dealing with. So when you guys are looking at bivariate data, that's what that means. You're looking at x's and y's, 2 different variables. You have a whole bunch of data. So even when you guys are looking at your tables, and you have your XY tables, and it says like 0, 0, 1, 4, 2, 8, whatever it is, two sets of variable data. So I got data points and I'm looking at XY data points. That's what bivariate means. So don't let that big word mess you up, and you do need to know that word. We're going to progress on it with that word, and that word's going to come up in other homework as well. All right, so there's your guys' to-do list. Watch your video, take some notes, do your Nearpod, finish that Google Slides assignment, and then some ST Math. I'm here on Google Classroom. I'm going to do a real brief Zoom with you guys, and I can leave the Zoom open, and you guys are welcome to come back in, and you guys can ask me any questions as you move through that assignment. I'll be available. Thanks, guys. Hey, good to see you. Let me know if you need anything. Thanks. Bye.